Behind the door, said he never saw the light before. And the kitchen clock I was going to wind said he never saw the light behind. Made millions.
If you think about the many millions of years that have gone into the evolution of the circuits in the brain that control movement, and you compare that to humans, where we've really only had hundreds of thousands of years to evolve some of these more elaborate human-level functions like advanced cognition and long-term planning, complex language, you begin to realize that it's very likely that a lot of these sort of higher-order functions, they're built from the same building blocks that movement is built from. And so I feel that if we can understand how the brain controls movement of the body, then we're going to get insight into everything the brain does. It's really the pieces that the nervous system is using to generate movement. They're sampled by evolution over and over again to build the many, many other functions of the nervous system. My name is Eiman Azim. I'm an associate professor here at the Salk Institute. I grew up in Denver, Colorado. My immediate family was me and my sister, my parents, of course, but big family out in Egypt where my parents were born. My parents had a huge influence on my motivations to pursue, gaining knowledge and knowledge that can help society. They both became passionate about engineering. My dad is a biomedical engineer and developed novel ultrasound technology for medical applications. My mom was a professor in electrical engineering for many years. As a kid, I liked being outdoors. I liked collecting rocks. I thought I wanted to be a paleontologist. I loved dinosaurs. I loved space. I was just curious about things. But it wasn't until I got to college that I really fell in love with science. When I was at Stanford as an undergrad, I entered thinking I was going to be pre-med, just like a lot of people come in, and I very quickly realized that the path that I wanted to pursue was less sort of prescriptive, like a lot of medical training is, and it has to be. And I kind of wanted to pursue ideas of exploring more of the unknown, which is, of course, what research is tasked with doing. But the sort of path into neuroscience was sort of an odd one. I got really passionate about philosophy, so I double majored in biology and philosophy, but I spent a lot of time in the philosophy department. Got really into questions of philosophy of mind. How do we know that we even exist? How do I know that you exist? But over time I got a bit frustrated that I couldn't definitively test them or answer them with experiments. So at that point I decided to invest a lot more heavily in the biology side of my college education. I joined a laboratory and my passion for neuroscience really took off from there, and headed off to Harvard for graduate school where I studied neuroscience. And there at Harvard, I really became passionate about developmental neuroscience, how the brain is built, what are the molecular cues that control how different types of cells organize themselves and connect to each other to build the brain and all of its functions. After I got my PhD, I joined a lab as a postdoc at Columbia University, where we were really at the cusp of now being able to use these genetic and molecular tools to ask questions about function. So in my field, we call this systems neuroscience. My mom's work in electrical engineering ended up having a big influence on the science I'm doing now, because it turns out that the kinds of questions I ask in how the brain controls the body are very similar to a lot of engineering questions. So when I go home and visit, I see these old textbooks on the bookshelf from my mom's classes, and I ask if I can borrow them. Control theory engineering has a big impact on the kinds of questions we ask. I was looking around the country and had some options. Most of them were large universities with neuroscience departments, departments like the ones where I did my training, which are fantastic places to deeply immerse yourself in neuroscience. But Salk was different. What I realized here is there's no departments, there's no boundaries between disciplines. So I was learning more about plant biology and immunology, cancer biology than I ever would have in a department that's focused entirely on one set of questions. My research focuses on how the brain and the spinal cord control the body. We're fundamentally interested in the control of movement. And there's several reasons that we're passionate about this. I think the main reason is, if you think about it, the primary evolutionary driving force of how the nervous system came to be what it is movement. If you don't move appropriately in the world and effectively interact with the environment, there's no reproduction, there's no eating, there's no breathing, there's no escaping from predators, so there's no evolution. If you think about the many millions of years that have gone into the evolution of the circuits in the brain that control movement, and you compare that to humans, where we've really only had hundreds of thousands of years to evolve some of these more, elaborate human-level functions like advanced cognition and long-term planning, complex language, you begin to realize that it's very likely that a lot of these sort of higher-order functions, they're built from the same building blocks that movement is built from. Really, the pieces that the nervous system is using to generate movement, they're sampled by evolution over and over again to build the many, many other functions of the nervous system. Another reason we're really passionate about movement is because a lot of people suffer from degenerative diseases and injury. And I fundamentally believe that until we understand what the pieces are, how they talk to each other, we're not going to be in a very good position for improved diagnosis and eventually repair. So we're trying to figure out what the pieces are, what they do, so that we can improve treatment for people who need it.